I know you've been waiting so long for this, but it's here. Derivatives of trig functions. We have a whole section dedicated to trig. Oh man, talk about your best day ever. I know, and we're in it. Oh, this is so cool. All right, before we get into the derivatives of trig, we are going to look at some limits. All right, so there's some common limits. The limit as x approaches 0 of sine of x over x is always going to equal 1. All right, this is so common. You have to know this. You have to know that one. Okay? So know that one for sure. And look, and this is the reason why it happens this way. So if I'm looking at my y is equal to, I'm going to make this bigger so you can see it better. Y is equal to sine of x over x, right? Here's our graph. This is literally the graph of it. So do you see what's happening to the limit? As I approach 0, what is my graph approaching? 1, right? And it's a limit. So it doesn't have to have a value there. And this one doesn't, because that puts a 0 in the denominator, right? However, my whole graph comes up here to 1. And that's a common one. So the limit as x approaches 0 of sine of x over x is equal to 1. All right. Here's another trig limit. Not as common. So as I'm approaching 0 of the cosine of x minus 1 over x, that equals 0. All right. So this one, just hang it out in the back of your mind. In the back of your mind. This one is not very common. Pardon me. So it's not something that you have to be able to recall immediately. Sine, yes. That's used a lot. But cosine, this cosine one, not so much. All right. But it's in there and it's worth talking about. So let's try this on. Let's see how we're going to actually use this. So here's example 1. Asks us to evaluate the limit. And A is the limit as x approaches 0 of the sine of 4x over x. Now here's the kicker. Let me squeeze this back. Here's the kicker. This inside function of sine has to be exactly the same. So, because this problem has a 4x, I need to figure out a way to get a 4x in the denominator. And remember, as long as you multiply the top and the bottom by the same thing, it's like multiplying by 1, so you're good. All right? So now, I actually have the limit. I'm going to make this bigger so we can see it better. The limit as x approaches 0, because have we taken our limit yet? No, it's an operation. Keep writing it. So 4 sine of 4x over 4x. And there it is. Right? That's the deal. So getting that set up is the key. This is now 4 times 1, which we know is 4. Not too shabby, right? Okay, let's do one more. I don't think, I might have enough room, but I'm not going to chance it. So let's go to the next page. Here's example 1b. I'm going to take the limit as x approaches 0 of the sine of 3x over the sine of 5x. All right. Now, something that we didn't talk about, but is still legit. The limit as x approaches 0 of x over the sine of x is still 1. All right. So the sign can be on the top or the bottom as long as the angle is the same. That's the key. That's the key. All right. So let's split this up and figure out what it is we have. We want to get the limit as x approaches 0 here of the sine of 3x over something times 1 over the sine of 5x. My goal is to make this a 5x, right? Because then they will be the same. And to make this a 3x because then they'll be the same. But in order to pull that off, I need a 5x on the top, and I need this 3x down below. But in order to multiply this out, I have to have the same thing. So I have to multiply the top by a 3 and the bottom by a 5 so that it's the same, right? I now have 3's, 5's, and x's. So 15x and 15x. It's the same. Do you see that? Okay, as long as you multiply by the exact same thing on the top and the bottom, that's all that matters. Okay, so now if we split this up, the limit as x approaches 0 here, I've got, I'm going to, I guess, put, I don't know. I've got the sine of 3x over 3x times 5x over the sine of 5x. But we've used an x, we've used a 5 for the top, but I have this extra 3. So I'm going to take, you can't just eliminate it. It's still there. Down below, I've used my 3x. And then this was what I already had. So I have this extra 5 left over. So I'm going to put that 5 in there. Do you see what just happened? Okay. Then I know this is 1 times 3/5. So my answer is 3/5. All right? And that's going to happen every time. Once we learn a new strategy, it's called L'Hopital, and once we know how to do derivatives and limits together, that's coming in chapter 4. Then we'll look at this problem a different way, because this is a 0 over 0, but this also is so valid. Using this common limit notation just makes it easier. All right? Okay, practice some of those.